Hey there, tech enthusiasts. Today, we're going to dive into the fascinating world of IEC 19249. IEC 19249 is an international standard that provides guidelines for the development and use of software for the construction, operation, and maintenance of information technology systems. It covers a wide range of topics, including software architecture, design, and testing. Let's talk about 5 architectural principles and 5 secure design principles, all designed to help us build strong and resilient systems. So, architectural principles. First up, domain separation. Think of your system like a city. You divide it into secure zones, each with related components like applications or data. Each zone, or domain, follows its own security rules. Here's an example. In a computer's CPU, the operating system kernel runs in what's called ring 0, the most trusted level. Meanwhile, user applications run in ring 3, the least trusted. This idea also appears in what's known as the Godwin-Messinger model. Next, layering. Imagine building a multi-story house. Each floor has a different purpose. In security, layers let us place controls at different levels and make it easier to validate that everything is working as expected. Think of the OSI model in networking. It has 7 layers. Each layer builds on the one below it, and together they help manage and secure the flow of data. Now, let's talk about encapsulation. This comes from object-oriented programming. Instead of letting someone directly change your internal data, you give them safe ways to interact with it. Picture a clock. You wouldn't let someone directly adjust the seconds variable. Instead, you give them a method called increment. It's all about protecting your data and avoiding mistakes, just like how IPs safely interact with a database. Moving on to redundancy. This one's all about keeping your system running, even when parts fail. Take a server with 2 power supplies. If one fails, the other keeps the server running. Or consider a RAID 5 setup with 3 drives. If one drive goes down, your data is still safe. Plus, parity checks help detect any corrupt data. And finally, virtualization. This is a big one in cloud computing. Virtualization lets multiple operating systems share the same physical hardware. It also provides isolation through secure sandboxes, which helps contain threats like malware and prevent them from spreading. Now let's move on to the secure design principles. First, least privilege. Only give people the access they absolutely need to do their job. For example, if someone just needs to read a document, don't give them permission to edit it. Second, attack surface minimization. Every feature in your system is a potential entry point for attackers. So reduce the features you don't need. For instance, on a Linux system, disable services that aren't being used. The fewer features, the fewer attack paths. Third, centralized parameter validation. A lot of attacks start with bad input, like code injected where a name should be. That's why it's important to validate all input. And it's even better if validation is centralized, managed from one place, like a dedicated library, so nothing gets missed. Fourth, centralized security services. Don't scatter your security mechanisms all over the place. Instead, group them together. Take authentication, for example, manage it through a centralized server. Just make sure it's highly available so it doesn't become a single point of failure. And finally, prepare for errors and exceptions. Things will go wrong, it's inevitable. So build your systems to fail safely. If a firewall crashes, it should block all traffic, not allow everything through. Also, make sure your error messages don't accidentally expose sensitive information, like memory contents or customer data. So, whether you're a software developer, a project manager, or just someone who's interested in technology, IEC 19249 is definitely worth exploring. Thank you for joining us today. If you found this information helpful, don't forget to like, share, and subscribe for more tech insights. Stay safe out there, techies.